All right, welcome everybody. In today's lesson, we're going to pick up where we left off with our discussion about logarithms. In the previous lesson, we learned the definition of a logarithm, we learned how to calculate some easy logarithms, and also how to use the calculator. Today, we're going to talk about logarithms more in terms of their relationship to exponentials, and we're going to start by reviewing our old friend, the transformations. Remember, we keep reminding you that they are never going to go away, and here they are again, specifically in terms of both exponentials and logs. A quick general reminder, remember that anytime you're talking about transformations, whenever something is on the inside, it means the opposite, and that's basically anything that is horizontal. So again, just to kind of color code it for you, anything that says the word horizontal is always going to do the opposite of what you think it might do. So let's go ahead and take a look first at the left side here when it comes to exponentials. On the left side, we have it in words. In the middle, we have it with f of x notation. And then on the right, it shows you specifically in terms of exponentials. Now, here's the thing. When it comes to the inside of an exponential means inside of the exponent. So if you are talking about horizontal shifts, left and right, remember, of course, you're going to do the opposite, but it has to be done inside of the exponent. So in the first one, 4 to the x minus 3, because that x minus 3 is inside, you would do the opposite, which would be 3 to the right. And then underneath, 4 to the x plus 2, again, because you're in the inside, you would do the opposite, which would be 2 to the left. When it comes to vertical translations, up and down, those are big values, which are outside, and you follow the sign up and down. When it comes to reflections that happen on the inside, that moves you over the y-axis, and then reflections over the x-axis is a negative on the outside. Again, when it comes to horizontal stretching and shrinking, that has to happen inside of the exponent, and again, you do the opposite. So 4 to the 2x would actually be a horizontal shrink of a half, and 4 to the x over 2 would actually be a horizontal stretch by 2. And again, just to kind of add a couple things here, we would call this a horizontal shrink and a horizontal stretch. And this x over 2 is the same as 1 half x. And then finally, with the verticals, when it comes to the verticals, it has to happen on the outside. So if it's a 3 on the outside, you're going to stretch it by 3. If it's a shrink on the outside, you're going to shrink it by a fourth. And again, for both of these, you might want to clarify these are vertical stretches and vertical shrinks. You're going to see those same rules happening over here on the right-hand side, but now you're doing it in terms of logarithms. One thing I would be especially mindful of when it comes to logarithms is you're going to go ahead and watch the parentheses. In order for something to be inside or outside, it has to be inside or outside of the parentheses. So again, when it comes to the horizontal, when they say inside, they mean inside of the parentheses, which means inside of the log, and you're going to go ahead and do the opposite. Then when it comes to anything that's vertical, it's going to be outside of the parentheses. Notice there aren't any parentheses at all, so that's how you would know that those are outside values. Other outside values include the reflection over the x-axis and the vertical stretching and the shrinking. And then again, anything that's horizontal is always inside and it's the opposite. So the negative on the inside here reflects you over the y. This 4x on the inside is a shrink by a fourth. This 1/3 on the inside is a stretch by 3. And again, we're going to differentiate between horizontal stretches and shrinks compared to vertical stretches or shrinks. And again, when it comes to parentheses, you want to be careful by what they mean by inside, because in order to be inside of a log, you have to be inside of the parentheses. So starting off with some kind of basic applications of those, I want you to describe, which means in words, what is happening from the F to the G. So if you take a look here at number one, numbers 1 through 5 rather, are exponential, and then 6 through 9 are logarithmic. So you're going to go ahead and make sure that you look at the appropriate left side or right side if you need to review. So starting with number 1, 2 to the x becomes 2 to the x minus 3, and then a big plus 1. So you're going to go ahead and again describe in words. So the minus 3 inside is going to be right 3. And then the big plus 1 is going to be up 1. Again, they mean the same things that they always did. Use the rules above if you need to. Be a little bit cautious here for number 2. Notice that the parent function starts off as e to the negative x. The transformations are only things that change from the f to the g. So you're not actually going to include that negative as being a transformation because it was in the original. So all you're going to do is address this big minus 5, which would of course be down 5. Here for number 3, your base is 0.4. So the transformations are two things. It's the negative that's inside and the 2 that's inside. So again, both of those are inside. So when it comes to the negative, that is going to be a reflection over the y-axis. And when it comes to the 2, that is going to be a horizontal shrink of a half. Remember, anytime the values are inside, they're the opposite. So the negative is a reflection over the y if it's inside, and the 2 actually means a horizontal shrink of a half. Here in number 4, again, if you take a look at the original and then take a look at the transformation, you have to address anything that changes. So the big negative on the outside, that's actually a reflection over the x-axis, and then up 6. Here for number 5, again, the 2 changes are the 2 that's up inside and the minus 4. So the 2 that's up inside, that is another horizontal shrink because you're doing the opposite of a half, and then the big is down 4. Hopefully you can see the changes just as easily if it's a log. So notice we're starting with log base 2 of x, and then you have a negative 3 that was not there before. Again, you have to list the transformations separately. So starting with the negative, that's a reflection over the x-axis, where the 3 is a vertical stretch of 3. And again, if at any time you forget the rules, you can always just look above. Again, look on the left side for the exponentials, look on the right side for the log rules. Here for number 7, notice we have log base 1/4, and then we're going to go ahead and address this 4 and this minus 5. So the 4 on the inside, that is a horizontal change. You always are going to do the opposite. So we're going to call that a horizontal shrink of 1/4. And again, opposite means the reciprocal. I would make sure you denote H for horizontals and V for verticals, since those are the kinds of things you'll have to differentiate between. And then down 5. If you're wondering for these, when you're listing them out, order doesn't matter. So as long as you have the right transformations, the order doesn't matter. Then you have this plus 3, which is on the inside, and the negative 4, which is on the outside. So the plus 3 on the inside, remember, do the opposite. So that's going to be left 3, and then down 4. Finally, you have the ln, and again, just a good reminder here, when you see the ln, remember that means base e, that special irrational e that we've talked about a couple of times now. Just good to remember what the base is. And then we have 2 changes. We have this 1/3, and then we have this negative on the inside. So the 1/3 on the outside is a vertical change, and you always do what it says if it's on the outside. So that's a vertical shrink of 1/3. And then the negative on the inside, that is going to reflect you over the y-axis. So in addition to being able to just identify them in words, you might have to go ahead and actually write an equation. So write the transformed function g of x, and again, order matters. So whatever order the problem is given to you, you have to make sure that you follow that order when you go ahead and write the equation. So here for number 10, let g be a reflection in the x-axis, followed by a translation 2 units to the left, and you're starting off with the function 3 to the x. So because you're starting off with function f, we're going to go ahead and create a new function. So we're going to call that function g. The first thing you notice is that when you're turning the f into the g, you have to start off with 3 to the x. It has to be some transformation of that. When they tell you to reflect it over the x-axis, you do that by putting the negative out front. When they tell you to go 2 units to the left, 2 units to the left means you have to do it inside of the exponent. And in order to go to the left, you would have to do the opposite, which is why you would do an x plus 2. So hopefully that color coding helps you a little bit. Let's go ahead and take a look at number 11. So now this is a log. So again, you're starting off with a log. Notice that because there is no base of that log, you assume it to be base 10. You don't have to write it, but it's good just to know that it's there. You are going to go 1 unit down, followed by a vertical stretch of 3. And again, order matters here. So the first thing you're going to do is you're going to take your F and you're going to rewrite it as a G. So you're going to take that log and you are going to go 1 unit down. So if you're going 1 unit down, the -1 has to be on the outside. And while you don't have to do it, some people prefer, if you were going to write parentheses, they would have to be around just the X. You would have to make sure that the -1 is on the outside. It's just as correct without the parentheses, but some people like to put them just so that they know where they're located. So I did the orange transformation, but now I have to do the blue. And when I do the blue, I have to stretch both pieces. So as I go to stretch both pieces, I have to stretch 3 in the front, and I also have to stretch this by 3. So in order to do that, I'm going to wind up with a 3 log of X, again, parentheses or not, and then actually -3. I have to have -3 compared to -1 because you had to stretch both of them. So again, order matters. Please make sure you do these in the order that they are given to you. Here for number 12, you have e to the -x. So again, notice that you already have a negative here. So you're going to have to make sure that that carries through with you. You're going to have to do a horizontal stretch by 3 and then a translation 2 units up. And again, order is going to matter here. So we're going to go ahead and start off with g of x equals. And we know that it's e to the -x. When I want to do a horizontal stretch, that means I have to do it inside of the exponent and I have to do the opposite. So I'm actually going to have a 1/3 there. And again, notice that that is inside the exponent and the negative is there because it was in the original. Followed by, I am going up 2, and that can just simply be a big +2 here on the outside. One more just to make sure we've got it. So again, this is a natural log of x. And remember, natural log means base e. Don't necessarily have to write it, but it's good to recall. You're going to reflect over the y-axis, and then you're going to go 4 units down. So start off by making it a g of x equals. If you want to reflect it over the y-axis, you're going to have to put the negative inside. So that would be ln of -x. And then it looks a little cleaner if you do put the parentheses. Again, you might want to get in the habit, although technically it would be correct if it wasn't there. And then 4 units down is a big -4. And again, just to color code that for you, there is your reflection and there is your down 4. So that's the first part of the lesson, making sure you can recall all the different transformations. That's going to become especially important when we are graphing next time, but it's also helpful in terms of what comes next, which is talking more about how logs and exponentials are inverses. Before we do that, though, I had taught you about something called the loop rule. Remember that the loop rule was the easy way for you to go from a log equation to an exponential and vice versa. Not only do I want to review that for those of you who might have seen that before spring break, but I also want to make sure that you know that you can loop in both directions. So if you take a look at the first line here, this is the one that I showed you the first time. You start at the base, loop to the other side, and then come back. That's how you go from the log to the exponential. And then you also start at the base of the exponential, loop to the other side, and then come back. That's how you turn it into a log. Directly underneath it is the same exact rule, except I've just switched the left side with the right side. I just want to make sure that you can loop in both directions. So how would you loop with the second version? Again, always start at the base, loop to the other side, and then come back. And same thing if you're starting with an exponential, always start at the base, loop to the other side, and then return. So I want to make sure you can loop both ways. So that's all I want you to do over here on the right. I just want to make sure that you remember how to do the loop. And remember, when you do the loop, everything you write should be a true statement. So in the first one, you're going to go from the 5 to the 2 and then back, which means that 5 squared equals 25. Right underneath, you're just simply looping the opposite direction. So 8 to the 3rd equals 512. Then for the next one, you're looping from the fourth to the other side and then back. So 1/4, we tend to put fractions in parentheses, equals 4. Then you're looping the other way, so 9 to the 0 equals 1. And please note, you could also write 1 equals 9 to the 0. So just kind of want to not only review the loop rule, but also make sure you are fine with whatever's on the left side versus whatever is on the right side. And if you just go ahead and take a quick look at those, either using your formula sheet from chapter 5 or using a calculator, hopefully you would agree that all of those statements are true. When it comes to the next page, I have those same rules for you over on the left-hand side. I just figured I would copy it for you again. And now we're going to do the opposite, which is writing each log into exponential. And again, just making sure that order doesn't matter here. No matter which way you're looping, you always start at the base, go to the other side, and then come back. And you have to start by writing the word log. So log base 3, which means it should be a subscript, full size 1 equals 0. Directly underneath, start at the 2 to the other side and then come back. So log small 2 of 8 equals 3. Then over here on the right side, start at the 81, loop to the 9, and then come back. So log base 81 of 9 equals a half. And one more time, just to make sure we've got it. So log base 7 of 1/7 equals -1. And again, please make sure if I wanted to write this as 1/2 equals log base 81 of 9, it is still 100% true no matter which side I put it on. So really, it's kind of up to you. Remember, when you're evaluating logs, the question that you're asking yourself is the base to what power gives you the full size number. So 3 to the what gives you 1. That is, of course, 0. Directly underneath, 2 to the what gives you 8. That would be the power of 3. 81 to what power gives you a 9? Well, that would be the square root, which is a 1/2 power. And 7 to a -1 exponent gives you 1/7 because negative exponents become positive by moving them to the denominator. So again, these should all be true statements as well, although you're probably not as good yet at knowing when they are or are not true. And then the loop rule, its most important application is in order to find the inverse. So hopefully you remember that logarithms and exponentials are inverses of each other, and that's just by definition. That's where the loop rule comes from. Remember back from chapter 5 that if you're talking about inverses, you always are talking about the opposite. The same steps that we did back in chapter 5 to find an inverse are still true. So here they are again. So step 1, if there's an f of x, you're going to change it to a y equals. Then you're going to switch the x and y. You're going to then resolve for y equals. And then you're going to just replace it with inverse notation. So here are 2 quick examples done for you, and then we'll do a bunch together. So here is what you would do if you were trying to find the inverse. So notice here in A, it's f of x equals 6 to the x. That is how you know, of course, that this is exponential. You're going to go ahead and do step 1, which means replace the f of x with a y equals. Then you're going to switch the x and y. So instead of y equals 6 to the x, you now have x equals 6 to the y. When you have done as much as you can using just regular algebra, you have to turn it now into a log. Why? Because if you start as an exponential, you have to end as a log. That's what it means to be inverses. Whatever you start with, you have to wind up with the other. So how do I take that blue and turn it into a log? Well, you're going to use the loop rule. So again, start at the 6, loop to the other side, and then come back. So you start by writing the word log. You have a small base 6 of a full size x equals y. That's as much as you can do. So now you're ready to just change it into inverse notation. Notice that I started by inverting my 2 sides. So if you wanted to show a step in between, you could rewrite it as y equals log base 6 of x. And then in your final answer, you're just going to replace it with inverse notation. So if you start with an exponential, you always have to end with a log, and then vice versa. If you start with a log, you always have to end with an exponential. So in B, f of x equals the ln of x plus 3. That ln is how you know you're starting with a log. You're going to replace the f of x with a y equals. Then you're going to switch the x and the y. So the x winds up by itself, the y winds up on the inside. Then I have kind of this extra step for you. All I do here is remind you that a natural log really means log base e. You need to know that because if you're going to do the loop, you have to know what you're starting with. So you have to remind yourself that it's base e. When you go to do the loop, start at the base, loop to the other side and come back. And then maybe the most important part here, notice how the y plus 3 is in parentheses. If the y plus 3 is in parentheses, you have to leave them together whilst you're doing the loop. So you're going to say e to the x equals y plus 3. You want to resolve it for y equals, which means you're going to subtract the 3. When you subtract the 3, it's a big minus 3 on the outside. And in your final answer, you're simply going to put it in the inverse notation. So again, you started off as a log and you ended up as an exponential. So we're going to go ahead and do quite a few of these together, making sure that you can find the inverse. All right, so our last set of problems for the day is making sure that you can, in fact, apply that four-step process and find the equation of the inverse for each of the functions below. And again, if it starts off with a log, it has to end as an exponential and vice versa. Notice that some of these, instead of being called f of x, are just called y equals. So if the first step is already done for you, then bonus. So in number 1, it's already a y equals. So you're going to go ahead and switch the x and y. So x equals 4 to the y. Since there are no other steps that I can take algebraically, I'm going to go ahead and do the loop. When I go to do the loop, you have to start by writing the word log. You're going to write a small 4 of a full size x equals y. And then normally we would call it f inverse. Because there was no f, you can just call it y inverse. And then I tend to prefer to write it on the left. So I could call that y inverse equals log base 4 of x. And that can go ahead and be my final answer. Just something to point out here, again, make sure that the 4 is a small subscript and everything else is a full size. And then if you wanted to use parentheses, they would go around this x, but it's fine if you don't. Remember, inverses means opposite. In this case, the only thing that's opposite is an exponential versus a log, but it'll get a little more complicated as we proceed. So here in number 2, it's already a y equals. So I'm going to go ahead and swap the x and y. So x equals log base 2 of y plus 4. Important to note here, the y plus 4 is inside the parentheses, so anything inside has to stick together. That means that it's time to do the loop. So start at the 2, loop to the other side, and then come back. Because there's already a log here, when you do the loop, you're getting rid of the log. So 2 exponentiate to the x equals y plus 4. Because of the fact that this is a big plus 4 that is now outside of the parentheses, you're going to go ahead and subtract it. So your final answer is 2 raised to the x. You have a big minus 4. And again, because you started off as a y, you can just call it y to the negative 1, which means inverse. Notice that here, the opposite of a plus 4 inside is a minus 4 outside, and the opposite of a log is always an exponential. If you look at 1 versus 2, notice I have the inverse notation on the left side of number 1, but on the right side of number 2, it matters not, so no worries on that issue. A couple more. So here in number 3, there is an f of x, so I'm going to start by changing that to a y equals. Then I'm going to swap the x and y, so x equals 5 to the y minus 6. And then here's the first time that we're seeing this today. If you were to try to do the loop, you would start at the 5, loop to the other side, and then come back. That would mean that the minus 6 would be left out of the loop, and that is not okay. You can only do the loop once everybody is included. So this minus 6 on the outside, I'm actually going to start by moving that to the right. I'm going to loop this as x plus 6 equals 5 to the y, not loop it, rewrite it. Again, you have to rewrite it first so that when you go to do the loop, nobody is left out. Now, when you try to do the loop, you're starting at the 5, you're looping to the entire left-hand side and then back, and that's considered to be appropriate. You're turning it into a log, so start with an LOG, base 5. If you're looping a quantity together, you're going to go ahead and put it in a parentheses, and then that's going to be equal to y. And your final answer, because it did start as an f of x, you can go ahead and call it f inverse, and that would be equal to log base 5, small 5, and then in parentheses, a full size x plus 6. Again, opposite. So opposite of a plus 6 on the inside is a minus 6 on the outside, and the opposite of an exponential is always a log. Couple more here just to make sure we've got it. So in number 4, here you might want to note that if there were parentheses, they would be around this 3x. So you do technically have to keep that 3 and that x together. So since it's already a y equals, I'm going to go ahead and switch the x and y. So x equals 5 times the log of 3y. Then before I go to do the loop, there's actually a couple things that are in my way. The first idea here is I have to divide by 5. So if you divide x by 5, you're going to get x over 5 equals the log of 3y. And then you have to remember that anytime you see an log without a base, it has to be base 10. So you might want to go ahead and add that in. Only now can you go ahead and do the loop. So start at the 10, loop to the other side, and then come back. So 10 to the x over 5 is equal to 3y. You want to go ahead and get that y all by itself. So normally you would divide by 3. For inverse purposes, it's a little bit easier if you multiply both sides by 1/3. So that's going to give you 1/3 times 10 to the x over 5 is equal to, and then you could call that y inverse. Notice I did put the parentheses there just because I want to differentiate between the base of 10 and then the 1/3 on the outside. And again, to confirm, everything is opposite. Opposite of multiplying by 5 on the outside is dividing by 5 on the inside, and then same thing for the 3's. And again, that's the inverse notation there. So to finish up the last couple, number 5, you have an f of x equals, so change that to a y equals. You're then going to switch the x and y, so x equals 3 to the y plus 2. If you tried to do the loop, the 2 would be left out, so you have to first subtract it over to the left-hand side. So x minus 2 equals 3 to the y. When there's nothing else to be done algebraically, it's time to do the loop. So you're going to go ahead and start by writing the word log, small base of 3. Anytime you loop something together, you're going to put it in the parentheses. And then again, in your final answer, because it started off as an f of x, you can go ahead and write it as f inverse. And then again, as always, just confirm that everything about your answer is the opposite of what you started with. So here in the final problem, I'm going to go ahead and start by realizing that it's already a y equals. So I'm going to go ahead and switch the x and y. So x equals the ln of 2y minus 1. Notice that the 2y minus 1 is inside the parentheses. You are not allowed to add the 1 or do anything until you've gotten rid of the parentheses. And the only way to do that is with a loop. You'll, of course, notice here that there is no base. And remember, if you see an ln with no base, it's an e. When you go to do the loop, you start at the e, raise it to the x, equals 2y minus 1. In order to finish, you have to resolve it for a y equals. So you're going to start by adding a 1, which will make it a full size. Then again, remember, you normally divide by 2, but for inverse purposes, it's a little nicer if you write it as times a half. So your final answer is 1/2 e to the x plus 1 in parentheses, and you can go ahead and call that y inverse. You could distribute that 1/2 if you want to. It really doesn't matter either way, so feel free to do so if you would prefer. So that'll do it for today, guys. After this lesson, you should be able to describe and identify transformations and then be able to find the equation of the inverse. So thanks very much for tuning in, and we will catch you next time.